Oh, hello everyone. It's May the 2nd. I just finished working. I never really want to work like today after I had a good session. I had a good training session. I had a good training session in the morning. Friday is always my heavy day. Although I did do a little bit too heavy yesterday in the snatch, so I'm a little bit worried this morning if I can really hit heavy on snatch again. Essentially, I basically did two heavy sessions back to back, and yesterday's heavy snatch is in the evening, so it's like around 8 to 9 p.m. And this morning it's like 8 a.m. I did another heavy snatch session, so it's like 12 hours in between the two. Definitely not good. Like I don't want to do this again, so I have to really control the intensity I hit on Thursdays. But anyway, I did hit like very heavy in this morning. I hit 175 pounds for the snatch, which is I think within 90%, maybe 95% of my max, and 215 pounds for the clean and jerk, also I think within 90% of the max. So it's pretty heavy, right? Really heavy singles. And the good part is I don't really feel that heavy. Snatch was heavy. Snatch was actually very heavy. I didn't even know how I got it, but snatch was heavy. Clean and jerk, like the jerk felt heavy, which is understandable because I did a lot of overhead work yesterday. But the clean was surprisingly decent, right? Surprisingly decent. Was it difficult? I mean, it's not easy, but and I did do a double bounce at the bottom, but it's I did in one shot, so that was surprising. Well, anyway, so that's not the real thing I want to talk about. The real thing is, uh, so I did a design work for a statistic analysis for I don't know like 3 weeks, 4 weeks, like almost did nothing else, just the design. And after the design for that is done, now we need to design a contract for the service that we're gonna write. So I'm responsible for one component, and that component needs to have configs. So I need to write a contract for this configuration. And boy, did it take long to finalize this configuration. I think it took 2 weeks, maybe 2.5 weeks to get the config. Like I just got it done, finalize it, but it was tough, very very tough. And I think I went through I don't know 3, 4, maybe 5 different versions, and then lots of back and forth discussions with people, and it was frustrated. It was frustrating at a certain point, but this is where you know I have like a strong opinion of how I wanted this to be done, and other people have their strong opinions, right? And then you start discussing, and eventually someone has to give, right? Someone has to give. And this is where I think I read that there's a saying, if two parties are arguing and both of them are rational, then the argument will eventually dissipate because rationally you can always reach the right decision. And this is exactly how it plays out. Like all of us have very strong opinions of how this config contract should be defined. And we present evidence, we present scenarios basically to show that our design is going to work, your design is not going to work. But throughout different iterations and pros and cons, benefits, and at the end, rationality wins. Right? We like all these opinions eventually merge into one, and we have our final version. Yeah, so it's frustrating, but at the end, I do feel it's also very rewarding. This type of design work is really rewarding because it helps you to get a better understanding of the whole system, right? How the whole system works, and it's kind of a view into, you know, we do software engineering. Like, what is software engineering? I think this is software. This is engineering. This is real engineering, right? I'm not sure. I mean, it can uh, the large language model do this type of thing these days? I'm not sure. Never run it through, Gemini or anything. We just straight ahead and then design it on our own. Um, I feel maybe, what, that this is actually a good practice. I can try Gemini and see if it can give us. But the problem is, if you try to use large language model for this, you will have to define the problem very well. Like, you really have to define it very well. And by the time you get a precise definition, then your definition is the config itself. That you've already done it, right? It's like the good ideas comes about after a lot of discussions, lots of back and forth, lots of brainstorm, and eventually, you'll realize, you know what, I want this feature. Oh, I don't want that feature. Like, these type of things, they don't come up just in one person's head. It does require bouncing, idea bouncing. Yeah, but the consequence is I just finish it, and then I have to do this now, and I want to go to bed before 12 o'clock, which is really not going to happen because I haven't even eaten yet. Because I did my evening session, and then, so I haven't really eaten anything except a protein bar. So a few more things to say is about this one. I read it and I understood how it's done. I think I can code it myself, but probably, I don't know, some other day. Lord, we just keep delaying this type of thing, huh? All right, what is this? Minimum domino rotations for equal. In a row, top, bottom represent the top and the bottom half of the ith domino. When we retain the ith domino so that the top and the bottom swap values. Return the minimum number of rotations so that all the values in top are the same. Or all the values in the bottom are the same. It's the same thing. It doesn't matter. Top and bottom is the same thing. Actually, it's not. It is not the same thing. It's just we can probably run it twice, right? Once we do top bottom, the other time we do bottom and top, and we pick the minimum of the two, right? Okay, so we want to find the minimum. So we basically swap, right? 5, 2, 6, 2, 3, 2. So we want to do the swap. Yeah, so this is 2 swap. I can see that. To find. Well, the first thing you do is you read through this whole thing and you say, I have a count of like the top, right? At the top, I have a count 2, 1, 2, 3, 4. 4 counts. 1 has a 1, 2, a 1 count, and 4 has a 1 count. This is top, right? So for bottom, we have 5 has a 1 count, 2 has 3 counts, 6 has a 1 count, 3 has a 1 count, right? Therefore, if you want to turn everything into 2, the minimum is 2. You have to flip it 2 times. So basically you're trying to say, okay, if I want to flip 1 and 4, are they pointing to 2? Right? And if they are not pointing to, then we basically cannot do it. And then you can say, okay, I want everybody 1. Then I say, are they all pointing to 1? Okay, yeah, we can go large to small, right? So large, so I But if I do this check, I do know their positions. Yeah, maybe it's better to use their positions, right? I can put the position here, so then I can check the position. But the thing is, if I do this check, then for each one, I have to run through everything. For each one, I have to run through everything. So this is not just a minimum rotation problem. It's also a feasibility problem. Right? It's a feasibility problem. Like, how do we handle this feasibility problem? Yeah, actually, this one's also work, right? So, because 3 can replace by 2, 6 can replace by 2, 5 can replace by 2. So, let's see. Let's get the indices out. So 2 is 0, 2, 3, 4, and 5. 1 is 1, 4 is 0, 1, 2, 3. 5 is 0, 2 is 1, 0, 1, 2, 3, 4, 5. 6, 0, 1, 2, and 3 is 0, 1, 2, 3, 4. Right? So if I want to do the flip so that everybody's the same, so I find the top, like I have 2. I need to find it's missing. Right? It's missing. So it's missing 1 and 3. Then I look at the bottom. Does it contain 1 and 3? And the answer is yes. Then we say this is possible. Right? And if I have a 1 and doesn't even have, then it's not possible. I have a 4, doesn't even have, so it's not possible. Or if there are no overlap. So in this case, let's say top 3 has 0, 5 is 0, 1, 1 is 2, 2 is 3, 3 is 4, right? Bottom is 0, 1, 2, 3, and 4, right? And so 3 has this, 3 has this. You produce a set 0, 2, 3, 4. It doesn't cover the entire thing, so it's not good. 5 doesn't exist, 1 doesn't exist, 2 doesn't exist. Okay, so now the question is, given 2, right, given 2 arrays, is there a fast way to find the size of their union? The size after we yeah, the size if we union them. We use a set. Oh, it's fine because the total runtime is O(n). Okay, so yeah, I think I know how to solve this. This is fine. It's not gonna time out. And I have to, and I actually am doing it right now. Learning C++. It's just no going away from this. It's time. It's time. Not doing things like this. Right? This is not really learning. This is just it doesn't help writing production code, right? This is not like how do you do a thread? Like I have no idea, right? I don't even have like if and def, right? I don't even have these preprocessor statement, right? So this is really not. It's just toys. These are just toys. find the indices of each element in tops and bottoms. Check the ones. Right. Check the ones that exist in both, and see if the set of their combined, if the union of their indices can cover the entire vector, right? If so, choose the one with fewer replacement. So this is going to be ON. It is going to be ON. But I have to do a map, an ordered map, int. This is going to be we can do a set, right? An ordered huh? There's no unordered set? Yeah, there is. Top indices. Bottom indices. So top indices, tops I dot add insert I. Bottom indices, bottoms I dot insert I. Okay. Then for res equal to tops dot size. Okay, so this is gonna be auto const auto this key value of top indices. Call it val, and this is indices, right? Okay, so what we want to do is if bot indices dot contains val and bot indices val dot union. Actually, I'm not sure. So hold on, let's not do this. Union of set union. All right, so I have a V, first, second, V, first plus 5, second, first plus 5, second plus 5, v begin, and this is iterator, resize. Okay, is there a better way? You can use 2 iterator template. You know what? I think what I will do is just be stupid. You have to loop anyway. Actually, I'm not sure. That is something I'm not sure. But I just feel this is a little bit convoluted. Input iterator, this. Output iterator result. So the output I have to set. Yeah, this they just copy and paste. Right? They just copy and paste. What the hell is n? Oh, that is a size. Because this is the iterator. And then v dot begin. V, where is v defined? V defined as 10. Oh, the maximum. And then you can put inside a v. But this it is the end iterator. Maybe I can do it. So instead of an order, is this? I think we can just do vector, right? We can just do vector here, and then this is just gonna be pushback, right? So we just do pushback, and then we need to union those, right? So okay, we'll do that, and we say std vector int v of size wow. Top indices vector I can do auto bottom indices val. Okay, bot indices declared with auto cannot appear in its own initializer. Oh, that was not right. So top eyes, bot eyes. Okay, so this shall be top eyes dot size plus bot eyes dot size, right? And then auto iterator shall equal to std union set union of top dot begin top dot and they are sorted. I think that's prerequisite, right? Sorted sequence. Yeah, but they are sorted by default. And then we have bot is dot start. Oh, what the hell did you do? Oh my goodness. Dot start. Bot. And then we have to have a v, right? Start end, start end, start end, start end, and v dot begin. V dot begin. Okay. Oh, it's not start. It's begin. And we say size is gonna be if it minus v dot begin is equal to actually we should say this plus one, right? If it's equal to tops dot size, that means we can then hold on, res shall equal to std minimum res and std minimum top. Oh, we need to get an n out. Alright, so we search for tops dot size. We have this and next one, this next one, this. Yeah, so that's gonna be n minus top is dot size, n minus bot, and this is dot size. Right, because top dot size minus is gonna get a smaller one, so blah blah blah, we get a smaller one, right? So if it's not, then it's just not, right? So we go through every single one. If it contains, that's good. If it doesn't contain, then we just ignore, and then we keep going until the end. Now function call, I think it's the size issue, so we have to go int. So at the end we say return res. Return res is larger than n. If it is, then -1. Otherwise, return res by itself. Okie dokie. Oh, that took a while. Let's see if it works. Looks good. Submit. Hopefully it's not too slow. It is not too slow, but definitely not a good performance. I bet there is a better way, right? 20 milliseconds, 7%. Alright, what is the better way? I mean, better way is not to I don't know what is the better way. I actually don't know. May 19th, 2022, October 19th, 2020. I wonder if this is the right solution. The solution works because eventually either A or B has to have the same number throughout. The possibility of using first number of each list. I don't understand. Either A or B has to have the same number throughout. So we can just check possibility of using first number of each list. So AA means base list, swap list, target. So we go base list. If it's not target, and if the swap list is equal to target, that way +1. Otherwise, or -1. So use this to ensure that if it's bad, it really is bad. So A is the base, B is the swap, and I use A0. Why we can't use just A0? I don't know, because in this case, it is A0 though, but I can swap it. Oh, I understood now. Yep. Either A or B has to have the same number throughout. So you have to get either the one in the A or either one in the B. Oh, holy crap. Okay. That makes sense. So I can do a counter, right? I do a counter for both. And we say, if I use this, what is gonna be? Let's see. So this solution is inspired by my previous attempt at this problem 3 years ago, almost 3 years, more than 2 years ago. That's the right way to say, right? The key insight is that after one of the vector has the same numbers, right? It must take either its own first value or the other vector's first value. Therefore, we just need to check the count, the number of swaps when all the values are either tops 0 or bottoms 0. Alright, so I do want to use this, but instead of doing this, I think we can do int and int. No, do a counter. Actually, you don't even need this as a counter. I just realized because it's dominoes. So the most is 6. So basically we can be a vector of int top counter. Yeah, top counter is gonna be 7, right? And then we will do the exact same thing for here, but this one we'll call it bottom. And then we do that. Top counter. Tops I plus. So this is going to be bottom counter bottoms I plus plus. All right. So now we have both. Just say if I use this, how many do I need? Or no, it's, you know what, just to see if it's possible. Yeah, I don't even need this counter. Why do you need this counter in the first place? Right? So we can just say check using tops 0. Hold on, let me think again. So we use tops 0, right? And then we want to know if it's possible. So we have to get bottom to match it. Oh, the bottom, then we have to match it. Check using tops 0. Match tops is base, bottoms to swap. Bottoms is swap. Okay, and then int all right, so basically for int I equal to 0, I smaller than n, I plus plus, if tops I is not equal to tops 0, and bottoms I is also not equal to tops 0. Okay, so that's when we break. Otherwise, we can just go through the whole thing and then count. Okay, so we do need a counter. I call it count, right? So if that's, oh, but you break out, how do you know if it's successful or not? I agree. We should probably do I equal to 0 here. And then we do I smaller than n, and we use a while loop. Okay, while this, if this we break out. Actually, it's more nuanced. If it's not equal, right, we have some logic, and then we say if this, then we break, else count plus plus, right? Count plus plus. And if it's equal, then we don't do anything. And then I plus plus, right? So once it gets out, that's why I need to write a function for this. We call it int get number of swaps. Okay, so we need is a vector int of base, vector int swap, and int target value. Okay. All right, I think I'll copy and paste this entire thing, because that is the implementation. I don't have a tops, it's base. Result. No, we don't need a result. I just need to count. Right, so while this base is not equal to swap, right, and then we say swap I is not equal to target. Then we break out. Otherwise we do this, and then we do this, right? So at the end we shall say if yes, if I is equal to n, which means it's successful. So return I is equal to n, which means it's successful. Then we return count. Otherwise it's unsuccessful. Then we return n plus 1. Right. So here we say top is base, bottom is swap. So we say res equal to std maximum res, not maximum, minimum res, and get num swap. So top is base, so top is base, right? Bottoms is this, and then we're using tops 0. Okay, and then res equals td minimum res get num swaps. Again, still tops. Actually, we can just do this. Bottoms 0. Right? And it doesn't matter because as long as we have a mismatch, it will just get out and we return n plus 1. And I think this is not right because I'm missing one. Okay. So std min res get num swaps. Now bottoms, right? Tops. Yeah, it is 4 scenarios. And in this one, it's still the same, but this should be bottoms. Right. And return is res larger than n. If it is, -1. Otherwise, res. Oh wow, this is looking very neat. Oh, I need to do Spanish soon. Hopefully this one is right. For one, I don't really need count. I don't need any of this. What is this bull crap? Output 3. This is wrong. This should be target. Right? If it's not equal to target, and if this is not equal to target, then we'll break. But if this is equal to target, then we do this. There we go. I think this will be fast. Yeah. This is fast. Good solution. And it's also good because I'm done and I can go eat.